Welcome to my session on the Oracle Real Application Clusters, or short RAC, family of solutions. My name is Markus Michalewicz. I'm Director of Product Management, Oracle RAC. And today I want to introduce Oracle RAC in a slightly different way to you. I want to show you that the Oracle RAC stack includes more than just the Oracle RAC database option that most of you will be familiar with. And I want to show you which products, layers, and features we have in addition to make Oracle RAC and the Oracle RAC stack the perfect solution for various environments and use cases. Therefore, I call this presentation the Oracle RAC family of solutions, a user's guide. I want to guide you, I want to give you help to see and understand how you can use Oracle RAC in your environment. Based on a brief overview of Oracle RAC, I want to show you how to introduce RAC in a step-by-step way for a smooth integration into your data center. I want to also show you what additional values Oracle RAC provides free of charge to make the use of Oracle RAC even more attractive. And I want to highlight how some of our customers have used consolidation to reduce costs in a consolidated RAC environment. Just so I could answer one question that we frequently get as part of Oracle RAC development or Oracle RAC product management, which is, shall I use Oracle RAC or shall I use Oracle VM? I want to address this question from a slightly different way. I want to say use Oracle RAC and Oracle VM or any virtualization technologies, because at the point of this presentation you will see that Oracle RAC provides benefit even though you're using virtualized environments. That said, Oracle Real Application Clusters hasn't changed over the last years too much, and that was on purpose. We have tried to provide you with a consistent architecture. Oracle RAC is a clustered database solution for high availability, HA, scalability, agility, flexibility, and elasticity. It's Oracle's premier shared disk database clustering technology, and it provides you a choice for administrator and policy managed environments. The difference is you can use Oracle RAC either in dedicated environments, in which case you probably want to use administrator managed deployment models, or you can use Oracle RAC for policy managed deployments, which means you standardize on Oracle RAC for all sorts of use cases. The benefits in either case are that Oracle RAC runs all database workloads. It is the foundation for database as a service. It scales out as well as scales up. And it provides the highest availability for the database, including flexible workload management. Workload and high availability these days go hand in hand, and Oracle RAC tailors to both of those. Now, if you look at the picture on the left, you will see that Oracle RAC provides you with an infrastructure and uses redundancy in each layer to provide this high availability. Starting from the bottom where we see Oracle Flex ASM, over the database server layer or tier in which the Oracle database would run, over the application tier where the applications would run and the users connect to in the first place. Oracle ASM, or here Oracle Flex ASM, provides not only mirroring but also striping to make your storage layer available and perform well. The same concepts of high availability and scalability apply on the database server tier, where you will find Oracle Grid Infrastructure, which combines Oracle ASM and Oracle Clusterware, as well as the actual database technology Oracle RAC, because Oracle RAC is an option to the Oracle Database Enterprise Edition. In the application tier, Oracle RAC can extend via its clustering technology, and it will make the applications more highly available and scalable. Overall, you have hereby a system which uses redundancy for failover, but also provides you with a scalable model in each tier. Now, this technology, what we call Oracle RAC, has been on the market for the longest time. Oracle RAC in its first version has been introduced more than 14 years ago. Oracle Database 9i came with the Real Application Clusters option as a successor to its previous version, the Oracle Parallel Server, which was on the market between Oracle 6 and 8. Now, Oracle Parallel Server had a completely different model from Oracle RAC, but it laid some of the foundational infrastructure that we use still in Oracle RAC, just in a far improved way. The difference between Oracle Parallel Server and Oracle RAC is the invention of cache fusion. Cache fusion is a technology in the database layer which makes RAC so scalable and so efficient. So ever since 2001, we have used Oracle RAC and the cache fusion technology to provide you with a high availability and scalable database clustering technology. Over the years, we have introduced more layers into the stack, which make this solution much better. As you can see, with Oracle Database 10G, for example, we have introduced Oracle Clusterware and ASM. Both of these solutions add to the stack and provide a generic solution for managing other applications in a failover cluster. With Oracle Database 11G Release 2 in 2009, we introduced a new renovated foundation for the database and other applications, and we introduced the little brother of Oracle RAC, which is Oracle RAC One Node, and thereby completed the solution that Oracle and the Oracle RAC stack provides in this area. We also laid the foundation for Oracle RAC to go into the new space, which we can call the cloud. So we used our technology that has been on the market on dedicated environments and now use it in the cloud with Oracle Database 12G going forward. Now, when I talk about Oracle RAC and the family of solutions, I distinguish the various layers we use in the stack, and I start with Oracle Grid Infrastructure. As I mentioned before, Oracle Grid Infrastructure combines Oracle Clusterware and Oracle ASM and provides them in a bundle. So if you want to install a RAC database, the first thing you need to do is deploy what we call an Oracle Grid Infrastructure home. This home will provide you with Oracle Clusterware and ASM. It doesn't provide you, however, with the database. So the family of solutions then extends to the database layer. And if you want to deploy a database, an Oracle database to be more precise, on the grid infrastructure environment, you can still choose to deploy a single instance database, but ideally you would take the next step and deploy an Oracle RAC One Node database, which provides you with a certain amount of high availability and scalability to some degree, because you can load balance the workload between nodes, but it doesn't provide you with the same scalability, flexibility, and agility that Oracle RAC would provide you with, which concludes the Oracle RAC family of solutions. Now, in addition to scalability and high availability, some of our customers like to consolidate, and Oracle RAC is the perfect foundation for consolidation. It has been for the longest time. Even back in 10G times, we have had customers consolidating and standardizing on the Oracle RAC infrastructure. With Oracle Database 12c, a new option has become available, which is called Oracle Multi-Tenant. This option provides a higher consolidation level and goes perfectly well with Oracle RAC, because Oracle RAC in the shown infrastructure would provide you with scalability and high availability, whereas pluggable databases or Oracle Multi-Tenant would provide you with the highest consolidation level. Together, RAC and Multi-Tenant built the new standard for Oracle database consolidation. From an Oracle Database 12c high availability point of view, Oracle has come up with 4 standard reference architectures, which are classified as bronze, silver, gold, and platinum. And as you can see here, in each level, there's a certain assumption regarding data protection and recovery from failures. At the bronze level, for example, it is assumed that data is protected by backups. So if you do lose data in this environment, you would have to restore a backup, which will then be your last restore point. In the silver level, however, high availability has already come up to a higher level, and we assume that for recoverable local outages, there is a means in place that will restart whatever component failed, either on the same node or another node in, for example, a cluster. From a data protection point of view, again, the backups are the main solution. That changes then in the gold level, where 0 or near 0 data loss is assumed, which means you have other means than just a backup, typically Oracle Data Guard or Golden Gate, to recover from failures or loss of data. There's also the assumption in the gold level that comprehensive HA and disaster protection is used, which means that you probably want to standardize already in the gold level on Oracle RAC One Node and or Oracle RAC, and have an additional protection against disasters such as Oracle Data Guard. The Platinum level then goes one step higher and considers the application to the degree that we assume that there is zero outage for certain applications and there is zero data loss. This presentation, however, will majorly focus on the Silver and Gold level and consider the local outages, which then are protected by Oracle RAC. That said, I want to now introduce Oracle RAC and show you how you can introduce Oracle RAC in your data center, in your environment, using a step-by-step approach. And following the outlined flow, I will start with standardizing on clusters. As I mentioned before, Oracle Grid Infrastructure, or short GI, combines Oracle ASM and Oracle ACFS. Oracle ACFS is the ASM cluster file system and comes for free with Oracle Grid Infrastructure. It also combines Oracle Clusterware. So now Oracle Grid Infrastructure combines all three aspects to manage any failover environment so that Oracle GI can actually be used to replace any third-party cluster solutions for failover purposes. The benefits are that the solution, if used for any Oracle product, such as the database, any other Oracle application, or any product that carries an Oracle prefix, in this case, Oracle Grid Infrastructure is free of charge. It provides cluster-based high availability, flexibility, agility, and simplified resource management. Because if you do use Oracle Grid Infrastructure for a standardized deployment, you over time get used to managerial aspects of it, which you can apply to any environment in which you use it. Alternatively, of course, you could use third-party solutions, but they do not provide this integration and managerial benefits. So the idea here would be to standardize on clusters to get the highest level of flexibility and high availability. I want to point out, though, that there is a deployment model for grid infrastructure in standalone environments, so environments that are not clustered, not even on hardware level. The reason we have this is for providing Oracle ASM to single instance databases which do not run in the cluster. And this is a perfectly fine solution as long as you assume that you will be staying on a single server. If you have only the plan to move out and perhaps include more servers in your environment, or maybe pool, then you need to anticipate that more servers need to be managed in the same way, which means you want to combine the servers on hardware level to be a hardware cluster and use Oracle Grid Infrastructure for the software clustering on top of it. If you want to do this, then you need to use Oracle Grid Infrastructure for a cluster deployment. That is a different deployment than the one for standalone environments. You can change between those two, between the standalone and the cluster environment, but currently this requires a reconfiguration. My recommendation, therefore, would be to use the cluster deployment always, regardless of whether you want to use a single instance database, a cluster database, or any other database that Grid Infrastructure could manage, such as MySQL. The good thing here is that even if you deploy Oracle Grid Infrastructure in a cluster, you would still not incur or cause more licensing costs. Oracle Grid Infrastructure, if used for any Oracle product, is free of charge, no matter in which deployment model you use it. So why not simply deploy it in a cluster environment all the time? Only thing you need to do is you need to have the servers clustered on hardware level. The rest will be taken care of by Grid Infrastructure, and I will show you the benefits in the following slides. However, if you consider the database, and especially the Oracle RAC databases, then the next step would be to standardize your database deployment based on Oracle Grid Infrastructure. However, remember please that even if you have a cluster, that doesn't prevent you from deploying a single instance database. The Oracle Single Instance Database already provides a rather rich set of high availability features which can be used either in a standalone environment or on a cluster in which Oracle Grid Infrastructure provides additional features. So when I say standardize on clusters, there is a different step on standardizing on databases. because you can still use the single instance database on your cluster, and you get benefits such as that you benefit from cluster inherent high availability, but also from Flex ASM high availability and a consistent management across all your databases, whether those be single instances or RAC databases, by using SRVCTL as the management tool. SRVCTL is a management tool that comes with grid infrastructure and manages all kinds of Oracle databases for exactly the purpose of consistent management. Now that said, let's look into how Oracle Flex ASM can provide you benefits even though you may still use a single instance database. For that matter, there are other videos of part of this program that will explain Oracle Flex ASM in greater detail. Here I will just give you a brief overview, and that assumes a certain familiarity with Oracle ASM, which again you may gain from following some of the other videos available in this program. However, if you look at this picture in the background, you will see that I have set up 5 nodes. And before Oracle Flex ASM, you would have found this ASM instance, which is now only shown on 3 of the 5 nodes, on all of the nodes in the cluster. While this may have caused a little bit more of resource utilization, this is not the main benefit of Flex ASM, because now we reduce the number of ASM instances, and that reduces some of the resource consumption. The main benefit, however, here now is that unlike in previous versions, Oracle databases do not assume anymore that the ASM instance needs to be co-located on the same node. Instead, the Oracle 12c databases understand that as long as there is an ASM instance running in the cluster, they can connect to it and use it for the purpose of disk management. Now, why is this beneficial? Because if a database understands that the ASM instance doesn't need to run on the same node, it will also understand that if an ASM instance fails on a particular node, there is no impact on the database. It can simply connect to one of the other nodes and the ASM instance running over there. I have now running an ASM instance on node 2, and if this one fails, my database instance that is running on node 2, here called RAC Database A instance, it would not be affected starting with Oracle Database 12c. The same benefit, however, doesn't only apply to RAC databases. It applies to single instance databases too. See this little ochre box on the right side which says single instance DB, abbreviated as SIDB? This single instance database will benefit from the failover mechanism that I've just illustrated as much as any RAC database would, because the failover mechanism for Oracle ASM is provided as part of Oracle Flex ASM in Oracle Grid Infrastructure 12c. So as soon as you use Oracle Grid Infrastructure in a cluster, you get this benefit and you can use it even though you may still use single instance databases. In addition to Oracle ASM, Oracle Grid Infrastructure provides ACFS, the ASM-based cluster file system. Oracle ACFS is a fully POSIX-compatible cluster file system, providing you with the ability to store any type of data anywhere in the cluster. In the example in the back here, you can see that ACFS will be available on any node in the cluster. That means you can store any type of file on the ACFS file system across the cluster. For example, if you have files coming from applications, or you have files that you need as part of an ETL process to be extracted and loading into a database, then you can store these files on ACFS anywhere in the cluster. So if you have a RAC database, you can extract the ETL files, for example, from node 2, 3, or 4, whereas in my example, I use a single instance database and extracting the ETL files on node 5. Applications, on the other hand, can use ACFS for storing their files anywhere in the cluster, and if they fail over, their files will be available no matter where in the cluster the applications may end up running. In addition, ACFS provides functionality such as snapshotting, replication, and security, which makes it even more convenient for you to use ACFS as a standardized file system, especially in the cluster, which is what you get with Oracle Grid Infrastructure free of charge. Now, even though Oracle Grid Infrastructure provides a lot of benefits and a lot of functionality already, there is additional benefit in standardizing on one of the two Oracle RAC databases. That is either Oracle RAC One Node or Oracle RAC. And the main benefits are better availability during maintenance operation, or better scalability in case you use Oracle RAC. But let's focus on the manageability aspect or maintenance aspect for a moment. One of the main things our customers complain about is not so much that the databases are failing, it is the time that it takes to patch and maintain them. So maintenance operations today take far more downtime than actually failures, than the actual part of failing over a database. When you use Oracle RAC One Node or Oracle RAC, you can use online rolling patch and PSU application, which means you can take down an Oracle RAC instance, for example, one node at a time, so that two other RAC instances are available during the time you patch the first, second, or third one. That said, with RAC One Node, we provide a feature called online database relocation, which will basically do the same thing, just there is a little bit more of time that it needs to apply the patch. Either of these two solutions, RAC One Node and RAC, will allow you to do rolling patching and thereby minimizing your maintenance operation time. The next step when introducing Oracle RAC is therefore using Oracle RAC One Node as a minimum. Even though I said before that single instance databases can be perfectly used on Oracle Grid Infrastructure, there are reasons to use Oracle RAC One Node as a standard database deployment. Now, before I come to the benefits, let's quickly look at what actually is Oracle RAC One Node. Oracle RAC One Node is a RAC-enabled database running only one instance normally, that is under normal operations. In case of a server or instance failure, the one running instance is started on another server in the cluster, which is called failover. So Oracle RAC One Node is a failover solution for the Oracle database, which is integrated with the Oracle RAC stack. That means it provides a lot of benefits over using third-party failover solutions, such as it will be faster, it provides you with online database relocation that minimizes plant maintenance operations, such as patching, and it is, as I mentioned, integrated into the Oracle RAC stack, which means if you ever see the need to have more than just failover, but have the availability that Oracle RAC provides, you can easily upgrade to a full Oracle RAC solution. Looking at the database failover case, Oracle RAC One Node provides standard database cold failover functionality, which means on failure of either a database instance or on failure of the whole node that hosted the database instance, or on any other failure that may impact the Oracle database operation, Oracle RAC One Node will fail over the Oracle RAC database instance, or RAC One Node database instance I shall say, to another node in the cluster. You can control which node will be the failover destination either of two ways. Either you use administrator managed or policy managed definition of where the database should land once a failure occurred, but in the end Oracle RAC One Node provides a standard failover solution in this way. Oracle RAC One Node provides faster failover than other third-party failover solutions. As you can see here, based on tests performed by some of our customers, third-party failover solutions can take up to 25 minutes to fail over an Oracle database after a failure occurred. Granted, the time may vary depending on your environment, the application use, and when the failure occurred, but as you can see also, Oracle RAC One Node provides a cluster failover in less than 5 minutes. And these are average numbers. We have seen many customers having these kind of numbers. And this is because Oracle RAC One Node is integrated into the Oracle RAC stack and can utilize features such as Oracle ASM and Oracle Flex ASM in a very integrated and efficient way. The real benefit of Oracle RAC One Node comes into play when maintenance is performed on a system, because Oracle RAC One Node provides a unique feature called online database relocation for better high availability. Online database relocation is the only solution on the market that can minimize downtime during scheduled maintenance operations such as patching, which means hardware, operating system, or database home patching, and resource reallocation due to demand. Online database relocation allows Oracle to start a second instance of the Oracle RAC One Node database on a second node in the cluster, relocate workload that's running in the previous instance or current instance, and then shut down this instance. And you can do this either for patching in a rolling fashion, or because you need to free up resources, in my case here on node 1, for other applications to use this cluster node. Online database relocation has virtually no impact on the application. So in other words, Oracle RAC One Node was already pretty good, providing failover times that are the lowest in the market. However, for maintenance operations, you can use online database relocation and you will be even faster according to tests performed by our partner and customer MTEL. That said, Oracle RAC One Node provides the best-in-class single-instance Oracle database availability. It provides better database consolidation, as you can consolidate multiple RAC One Node databases on a cluster, and it provides better database virtualization by means of being able to relocate database instances across nodes in the cluster transparently to the application. That's why we call it online database relocation, and you can do it on a per database basis. Most of our customers associate such features with virtualization technology, which provides such features as live migration, where you migrate a whole VM. Oracle RAC One Node, based on a physical or virtual cluster, provides the same benefits, but faster and on a per database basis, which gives you more granularity. It uses a standardized and improved deployment and management because all your Oracle RAC databases, whether it be a single instance, RAC One Node or RAC database, can be managed using SRVCTL in an Oracle cluster provided by Oracle Grid Infrastructure. And thereby Oracle Grid Infrastructure is confirmed as one of the underlying infrastructures for any environment. However, there is one more step we can take, which is to upgrade to a full Oracle RAC environment. Now the interesting part here is that upgrading from Oracle RAC One Node to Oracle RAC can be performed online. In other words, if you want to change your RAC One Node databases to scale out or to provide higher availability just by having two instances running at the same time, you can simply convert your database, which is one command using SRVCTL, and you will find yourself in an Oracle RAC environment. However, this may be subject to licensing, so please contact your sales rep before you do this. Technically, it's an online upgrade. You will not interrupt your application, and thereby you have the highest level of flexibility and scalability based on Oracle Grid Infrastructure, standardized on RAC One Node, and then going to Oracle RAC, which concludes again the family of solutions. I don't think I have to introduce Oracle RAC in detail again because we talked about it for the longest time now. Just again, it is a clustered database solution and it runs all database workloads. It is the foundation for database as a service environments. It scales out, it scales up as demand requires it, and it provides the highest availability for the database just because it is always running. And this is perhaps the most distinguishing characteristic of Oracle RAC compared to Oracle RAC One Node. In Oracle RAC One Node, just to reiterate, you have one instance running for most of the time. If this instance goes down, either due to a failure or to maintenance or due to maintenance operations, you will restart this instance on another node in the cluster, which is why the cluster is so important. We call this operation always on because if you do it fast enough, it appears that the database has been always available. However, in a RAC environment, you have the always running environment, which provides you with a higher level of availability just because you do not need to start an instance upon failure of one instance in the cluster. You have already other instances running. Following high availability paradigms, not having to start for failing over is better than having to start. This is where the high availability benefit comes in. Of course, scalability is independent because now you have multiple instances running on multiple nodes in the cluster. again, should one instance fail, either due to maintenance or failure, you have those taken over your workload. This is why Oracle RAC provides the best availability for an Oracle database in general. From a failover times perspective, you can now see that the more you go up in the hierarchy, the more you standardize on Oracle RAC, the more you increase high availability and reduce failover times. As discussed, third-party failover solutions can take up to 25 minutes, depending on the environment and the workload, to fail over. Oracle RAC One Node, also as discussed, can take a few minutes or will take only a few minutes to restore the failed instance. In Oracle RAC, as you already have instances running, there's virtually no disruption in case of a failure. But there is additional benefit that we provide with Oracle RAC and the Oracle RAC stack, which you can use free of charge, and you should use because you are now in a clustered environment. Two of the benefits I want to discuss quite briefly on this slide. One of them I have already mentioned, which is ACFS. The ACFS cluster file system, again, is a fully POSIX compatible file system which you can deploy in your cluster, and it will be the ideal foundation for either application files, ETL files, or starting with Oracle Database 12c, even database files, because it also provides additional functionalities such as snapshotting, replication, and security, which can be applied to Oracle database files. I'll give you two examples where you can use Oracle Grid Infrastructure and ACFS, regardless of whether you use Oracle RAC or an Oracle RAC One Node database free of charge. One is, you have a single instance environment, Oracle Database single instance environment that is, and this single instance database is protected by Oracle Golden Gate. Oracle Clusterware, part of Oracle Grid Infrastructure, can be used to fail over the Oracle Golden Gate processes within the cluster, and the trail files for Oracle Golden Gate can be hosted on ACFS. Another example would be you have a MySQL database. You can host the MySQL database on ACFS regarding the data files and use the Oracle Grid Infrastructure bundled agents, which come as part of Oracle Grid Infrastructure, to fail over your MySQL database instances between nodes in the cluster, and that cluster would be an Oracle Clusterware-based cluster. So here you can see two solutions, two environments in which Grid Infrastructure will provide you additional benefit with other Oracle products such as Golden Gate and MySQL free of charge. On the right side, you see a new cluster topology which is called the Flex Cluster. And the Oracle Flex Cluster is a new standard for flexible resource management that you can use with Oracle Grid Infrastructure 12c going forward. You can use Flex Cluster as demand requires it, which means you can enable it either during installation or post-installation of Oracle Grid Infrastructure and Oracle Clusterware. The benefit, however, is that you now have one cluster solution that combines the database layer and the application tier or the application layer. One of the requirements that we have heard from customers is that they would like to have dependencies between their application and the database. Dependencies such as you have a group of application servers which you need to start. You can do this now by using Oracle Clusterware and the Flex Cluster in particular to manage this. You can also say, I have 25 application servers, for example, that need to start, but I also at the same time need to start one database instance. That is a dependency and a ratio. You say one database instance can serve 25 application servers. If you now start more application servers, you want to start more database instances. This kind of dependency can be expressed, modeled, and executed upon using Flex Cluster. Now, why would we use Flex Cluster over a standard cluster? The benefits here is that we use hub nodes and leaf nodes. Hub nodes would host your traditional databases and are connected directly to shared storage. Leaf nodes do not have the requirement to be connected to shared storage. Instead, they can just have their local storage and do not even need access to shared disk. In addition, leaf nodes are not talking to each other. They talk to the hub nodes for cluster operations. That means they are more efficient for non-database solutions such as applications. They also run a slightly lighter weight stack, and they can benefit from virtualization. In other words, in traditional cluster environments such as the Oracle cluster based on Oracle Clusterware, you could either have all your nodes being physical nodes or all your nodes being virtual nodes. However, our customers tell us that they would like to run their applications on virtual nodes and the databases on physical nodes. Yet they would like to have the dependency that I formerly described. In this case, you can use Oracle Flex Cluster and deploy leaf nodes which have the lighter stack, do not require shared disk, and are not so communicative between each other on virtual environments, and deploy your hub nodes on physical environments because they do need shared disk access because they will be hosting the database. If you would like to get more details about Flex Cluster, other videos as part of this program will go into those details. Two more added values come as part of the Oracle RAC stack. One is application continuity, which ensures that your application will be uninterrupted despite any database instance failure. The other one is quality of service management, which enables you a smooth ride, if you want to say it this way, in your cluster and ensures that the various workloads will be managed constantly real time so that you do not encounter resource shortage for your most critical applications. Again, quality of service management will be covered by other videos as part of this program in detail. So let me briefly walk you through application continuity and Oracle Transaction Guard. These two are features that come with Oracle Database 12c. More precisely, they need to be used with Oracle RAC One Node, Oracle RAC, or Oracle Active Data Guard as far as deployment models are concerned. Because what application continuity provides you with is with the ability to hide any kind of failure on the database layer towards the end user. One of the things our customers have always told us is that Oracle RAC, Oracle RAC One Node, or Oracle Data Guard, Active Data Guard if you want to include it, provide a good level of high availability on the database instance or complete database level. However, as long as an instance fails, there will be transactions that are in flight that get lost or interrupted. So an instance failure, as much as the instance can be recovered or the workload can be continued on another instance in the cluster, depending on whether you use RAC One Node or RAC as a solution, an instance failure can cause transactions to fail, and these transactions have in-flight operations that need to be recovered, because if you don't recover them, you rely on the application for you to recover those failures. Now that said, if you use application continuity and a feature that comes with the 12c database, which is Transaction Guard, these failures can be masked. So application continuity will mask many hardware, software, network, storage, and any other outages towards the end user by using a special driver on application layer and the Transaction Guard on database layer. This solution together will enable and improve end user experience and increase productivity without requiring custom application development. Again, application continuity and Transaction Guard will be covered in more videos as part of this program. So here I just want to show you that Transaction Guard and application continuity are features that can be used free of charge together with RAC One Node and RAC databases, and thereby provide additional value over third-party applications and solutions. Another aspect which you should consider if you use Oracle RAC or the Oracle RAC stack as a whole is that you can reduce costs further if you consolidate. The benefits of consolidation are easily summarized. Share the benefits and reduce the costs. In short, consolidation describes running multiple workloads in a shared infrastructure and allowing for standardized deployments, dividing the costs across multiple projects. In more concrete terms, what it says here is, don't look at a RAC or RAC One Node database as a dedicated environment deployed on a certain system for one application. Consider using the RAC stack as a shared infrastructure, consolidating multiple projects on this infrastructure, and thereby divide the cost across them. In short, the benefits therefore are cost savings. You can use a standardized deployment with your shared infrastructure, and you will be actually able to deploy applications faster and thereby reduce your time to market. The cost sharing across projects is then an additional benefit based on the consolidation. One of our customers has actually spearheaded this approach, and this customer is Commonwealth Bank of Australia. The Commonwealth Bank of Australia is Australia's leading provider of integrated financial solutions. And what they have done is they have started looking into consolidation as part of a project that they called Oracle as a Service back in 2007. The first version of Oracle as a Service went live in May 2008. And in a nutshell, what they have done is exactly what consolidation describes. They host many Oracle database applications on a cluster of hardware. And they use processor consolidation, which means they run each server hotter to saying with a higher utilization rate. And they take advantage of complementary workload peaks, which means if you have two applications that peak at different times, you can easily consolidate them on one set of hardware because they are complementary as when they take their peak. They provide also higher availability because they can load balance. They have an HA failover for component failures, as we already discussed, and that's maybe specific to Commonwealth Bank of Australia. They use a standby DR, which can be part of the whole concept, but isn't necessarily part of the shared infrastructure as described in this picture in the background. They, that is Commonwealth Bank of Australia, was able to reduce their costs and provide better service at the same time. Because now their DBAs, their administrators are full-time experts. They have a shared infrastructure which is standardized. There's no assumption how it's been set up. Every application that's been deployed will be deployed on a standard defined set of hardware and software and will thereby benefit and utilize the same functionality, which means you do not have to look into things on an individual basis. The other aspect to this is it will reduce your risks. If your administrators know your system and your system doesn't change, you reduce the risk for human errors because the administrator may have made a wrong assumption when operating on the system, or more likely when responding to a failure case. So this is what Commonwealth Bank of Australia did. CBA really optimized their consolidation approach. Not only were they able to reduce the risk, improve the time to market, they also significantly reduced the deployment time and costs. For example, for a new project, their time to initiate a new production quality environment went down from 3 months to 2 minutes. Another example would be the deployment of ISV applications that they want to introduce into their online share trading platforms. Before Oracle as a Service, using dedicated infrastructure, this deployment would have taken them 3 to 4 months, whereas now with Oracle as a Service, it takes them a few hours. And the deployment costs went down from several $100,000 to less than $10,000 per deployment. This is a benefit of consolidation that you can get too, and you can get it really regardless of whether you use Oracle RAC on dedicated and physical environments or in virtual environments such as Oracle VM. A lot of our customers look at virtualization and virtual solutions to benefit from consolidation. As you have seen with the CBA example, using Oracle RAC and the Oracle RAC stack, you do not need to use virtual environments to benefit from consolidation. The Oracle RAC stack provides enough features, technology and functionality so that you can benefit from consolidation even though you're using physical environments. However, if asked by a customer of whether or not RAC has benefit in virtual environments, my answer to this question is clearly yes. Because the requirements regarding high availability and scalability do not go away just because you virtualize your environment. In other words, if you use your virtual environment to run an Oracle RAC database, or for that matter any Oracle database, requirements regarding high availability and scalability remain. In this context, you can look at virtualization as simply a different way of hosting an Oracle database, but as you have seen in the previous part of the presentation, the Oracle database needs a certain environment to provide better high availability and scalability, of which RAC is a major part. So that said, here is a way of looking at virtualization maybe in a slightly different way than most of our customers would do it at first glance. And I'm not meaning it any negative when I say virtualization is basically a black box approach. What you have is two physical environments, you could have more, here symbolized by two bare metal servers on which you deploy a hypervisor just so you can host a virtual environment. As we are in an Oracle environment, I will assume you use Oracle VM, but any other and similar solution would work. Now, if you deploy your virtual machines, here called guests, on these two different and independent physical environments, what you basically do is you provide a black box on each of these environments. In my case here, I have 4 guests deployed pairwise on the 2 bare metal servers. Now, from a virtualization layer point of view, these two pairs of guests are actually black boxes. They may run whatever the customer chooses to deploy within these guests. So that way, I refer to the guests as a black box. Granted, there's many ways of benefiting from virtualization. For example, if you have a resource shortage on one of the physical servers, here the left bare metal server, you could use technology such as live migration to move a guest from one physical environment to another. That way there is workload balancing on a VM basis. So in other words, the black box can be moved from one physical environment to another, and that is called workload management because you take work of one environment and take it to another. However, the virtual environment does not know what work is running inside the guest. It just bases the guest based on its dimensions, memory and CPU assignment typically. The same applies if you look at failure cases. Let's assume you use VM environments and you use HA provided as part of VM solutions. What that means is there is a layer in your stack that monitors your guest, and upon a failure of the guest or the VM, it will either start to restart it or relocate it to another environment as shown in my animation. However, what's missing here is the insight into the guest or into the VM. In other words, what happens if my guest runs a database? And what happens if this database fails? Or for that matter, any other subcomponent needed for the database. Let's think of a listener, for example. So with the VM approach, the VM and the guest would be unaware what's running in it, such as a database, and what's failing. It would only react if it is recognized that the guest as a whole doesn't operate. If the database fails, or for that matter smaller components such as a listener, there isn't necessarily immediately a corrective action performed by the virtual environment. Therefore, you still need to have an infrastructure that protects your databases and related resources such as the listener or other things that you need for clients to connect to your data. If I look at a virtual environment and I deploy a database such as here, I can still see necessity for using a RAC database, which is what I'm actually using here. So just to give you an explanation of the graphics, I still have my two physical bare metal servers, and I've deployed two guest pairs. One is blue, one is gray, and each one of these two guest pairs hosts one RAC database. One is called database A, the other one is database C. Database B runs somewhere else. Now, in each guest, I have an instance of either database B or C. And if you focus on the gray guest pair in the middle, I have database C1 and C2. And I use a per node home deployment, which is what this little house and the little database in the background symbolizes. So in other words, my database software, my binaries, reside as part of the guest within the VM and is therefore what we call a per node deployment. If you look at this picture and you assume then that there could be failures to the database instance, then what I have said before, and actually as part of the whole presentation, still remains. If a database instance fails, there needs to be a layer to correct this. Either restart the instance or fail it over to another node, depending on whether I use RAC One Node or RAC. Here I use RAC, so what I need to make sure is that if an instance fails, my other instance continues operation. And that same paradigm holds true whether I use physical servers or virtual servers as shown here. Remember when I talked about planned outages such as maintenance operation? Same paradigm applies. Assume you need to patch either the operating system within a guest or the database home. I still need to patch my home or my operating system on a per guest basis. So no technology that helps me moving a virtual machine or a guest as a whole will help me patch it inside. That's where Oracle RAC and RAC One Node provide the additional benefit. As shown in my example here, I'm about to patch the guest that is hosting database instance C1. Now if I do this, what I do need to do first is I need to take down my instance, patch my home, and bring my instance up. This is called a simple patch. Now if I have a RAC database, or for that matter a RAC One Node database, I can do this rolling across the nodes in the cluster. So in other words, here I have two instances that need to be patched, two homes that need to be patched, because the home is on a per node basis. So same applies. I take down my database C2, I patch the home on that node, and I bring it up. This procedure by itself is called rolling patch application and can be performed, as previously mentioned, on RAC One Node and RAC databases, but most importantly, remains the same of whether or not the RAC or RAC One Node database is hosted in physical environments or in virtual environments such as shown here. Concluding, to me, Oracle RAC and Oracle VM, or any virtualization technology for that matter, are complementary. Could you use Oracle RAC on physical servers? Absolutely. If you standardize on virtualization, would you still want to use Oracle RAC? Absolutely. Summarizing, I come back to what I've talked before, which is the Oracle Database 12c High Availability Standard Reference Architectures. As you will remember, we have 4 of those standard reference architectures classified bronze, silver, gold, and platinum. Now, as we discussed, each individual layer has certain assumptions regarding data recovery and failure recovery, which we discussed. If I now was to map which solution I would use in each layer, here is what I would propose. Even in the bronze level, I would standardize on clusters. Now I fully understand that some bronze level deployments, even though the cluster standardization wouldn't cause any licensing increase in costs, do not require clusters at all. There are certain deployments in which a cluster would still be an overhead because it could be simply deployed on a single environment. That's fine. However, if you ever think that this deployment could go into a higher level of high availability, you may want to consider deploying a cluster instead of a single instance or single standalone environment. That said, for Bronx, the mapping would be no cluster required, but there is benefit in standardizing on clusters using single instance databases even in the Bronx level. If you then have a deployment reference that is called Silver level, Oracle's recommendation is clearly to use a failover cluster at a minimum. In other words, a high availability cluster. Following the course of this presentation, you would want to deploy a RAC One Node as a minimum, because RAC One Node is the integrated, fully supported and optimized failover solution for the Oracle single instance database. If you then proceed up, and even for applications in the Silver level going closer to the Gold level, you would then look into standardizing on Oracle RAC, because this is the highest level of availability for local outages that you can achieve given the Oracle database is used. And last but not least, there is a Platinum level which considers application and the use of application continuity, for example. And here I would recommend that you use Oracle RAC and application continuity for local failures. You can extend this idea to active data guard environments, but this isn't part of this presentation, and other videos as part of this program will provide you with more details. This concludes my presentation. Thank you for staying with me. Thank you for your attention. As I mentioned earlier on, this was an introductory video. I will be providing more videos on more technical manner, so looking forward to talking to you again. Thank you again and have a good day.